In exercise 4,4, there are two types of examples that have not been covered in the worked examples. And as these are a little bit sneaky, I decided I would do them with you as well. Take a look at this function over here. This is very difficult for you to see. How are you going to find the highest degree of x? Now what you need to remember is, if I had the root of x squared, the answer is in fact going to be x. So if I have an x squared underneath a root sign, that's the same as having an x anywhere else in my expression. In other words, in this example, when I divide by the highest degree of x, I'm dividing everything actually by x. But when I divide by x in the numerator, I'm just dividing by x. But as my expression is terms underneath a root in my denominator, I must divide everything by the root of x squared. So let's do that in the next step. What I've done over here is I've just written out the information that I had before. The highest degree of x in the denominator is in fact x, but as it was under a root, I must divide everything by the root of x squared. So dividing all of the terms under that root by x squared. There was no root in the numerator, so then I divide all the terms by x. Now you can see I can cancel, and I can see what my answer is going to be. This limit, when I simplify it, is still finding the limit as x tends to infinity, but in my numerator, I'm going to have 4 plus 1 all over x. Now you know that that 1 over x is tending towards 0. So that means that it looks like in my numerator I only am going to have a 4. In my denominator, I am going to have the root of 2. Let's write it all out for you. It's the root of 2 plus 5 all over x squared. Taking a look at this now, remember, the fractions that I'm allowed to disallow are the ones that are tending towards 0, which is 1 all over x, and then the root of 5 all over x squared. If these are tending towards 0, I'm just going to be left with finding the limit as x tends to infinity, which is 4 all over the root of 2. In other words, I'm going to have a horizontal asymptote when y is 4 all over the root of 2. This is a difficult problem over here because every single time that I've manipulated, I've been given a fraction. Now you cannot manipulate something if you've got a numerator only, because you're going to change the meaning of the expression that you've got. If you get something like this though, and you times the top and the bottom by the conjugate of the expression that I've already been given, you're going to be able to create a fraction for yourself. So as I've been given this information over here, and this was all over 1, let's draw a nice long line, and I times it by the conjugate of what I've got in the numerator, that means that I must times it by the first term, the root of x squared plus 4x, and then the opposite sign, plus x. But if I do that in the numerator, and I don't want to change the value of my expression, I must times it by the same in the denominator. In other words, that conjugate over itself is timesing by 1. Now by multiplying out the brackets in the numerator, a root times a root is a root squared. In other words, I'm going to have x squared plus 4x. The middle terms cancel out, and I have minus x squared. In my denominator, I'm going to have the conjugate, which is going to be the root of x squared plus 4x plus x. Now I'm able to assess what my highest degree of x is. As I've got a numerator and a denominator, I can divide everything by that highest degree of x. Now, can you see that I've got an x squared inside my bracket, but just an x on the outside? The highest degree of x is in fact going to be x, because the root of x squared is x. Looking also at my numerator, I should have told you that these two terms cancel out, and so the degree of x in the denominator is the same as that in the numerator. In other words, it looks like I am definitely going to have a limit. If I write this out so that you can see what I'm dividing by, my expression will be 4x all over x, and then in my denominator, I'm going to have x squared under the root, so it's divided by x squared, plus 4x, still under the root, so divided by x squared, but this x is outside the root, so I just divide it by x. And now cancelling common factors, I'm able to cancel the x in the numerator's fraction, I'm able to cancel all the x's in the first term under the root, and I'm able to cancel one of them in the second fraction under the root. The number outside the root has all my x's that are going to cancel out. In other words, if I write this now in simplified form, I'm going to get the following. In my numerator, I have just 4. In my denominator, I'm going to have the root of 1, and this is this number over here, plus 4 all over x. But as that tends to 0, I'm not going to write that down. So I'm going to have the root of 1, and then x all over x is also 1. So in other words, I'm going to have the root of 1 plus 1. As this is all numbers and I've been able to get rid of the fractions that are tending towards 0, my answer is going to be 4 divided by the root of 1, which is 1, plus 1. And 4 divided by 2 is going to give me an answer of 2.